22 to 4 coulombs law. Q1 unit Q2 only apply to point charges. Force is a vector. Direction is along the line joining two particles. Attractive/repulsive for unlike/like charges. Coulomb's law, example. Consider the forces between the proton and the electron in hydrogen atom in the ground state, lowest energy, where the distance between is 0.53 by 10 meters. Gravitational force. Observations. At atomic level, one may ignore gravitational force. Atoms are stable because of strong electrical interaction. We typically experience gravitational force or electrical force. Back to the soda can experiment. Can you make soda can positively charged? Superposition principle. In a system with multiple charge particles, the net force on one particle due to other charges, two or more, is the vector sum of each force due to each individual charge, and each individual contribution is unaffected by the presence of the other charge. Superposition principle, an example. Assume Q2 and Q3 carry same type of charges but opposite to Q1, calculate the total force on Q1. Q1. Q3. Q2. Step 1, calculate F12. Step 2, calculate F13. Step 3, calculate F. Q1. Q2. Q1. Q3. 23 to 2 electric field unit for E, NC. Again, only applies to point charges. What is field? A field is any physical quantity that has a value at every location in space. Its value can scalar field, or a vector field. Scalar field, temperature Tx, y, z. Vector field, airflow in a room Vx, y, z. 23 to 2 electric field, cont. E field is a vector. Measure an E field. Using a test charge Q2 and measure the force acting on Q2. Superposition principle is valid. Concept: check the E field at point P1. Along plus X. Plus Q. Q. P. X. Y. The E field at point P. 1. Along plus X. 2. Along X. 3. Along plus Y. 4. Along Y. 5. Another direction. Field line always goes from positive to negative charges. Direction of field, tangent to field line. Strength of field, density of field line per unit area. Field of continuous charge distribution. Evaluate the contribution from a small charge element, dq, the. Don't choose a special point. Don't perform detailed calculation. Do decompose the dA into components, vertical bar and to the symmetric axis. Coordinate. 2. Exploit symmetry. If one component is 0, do not calculate it. Concept check, symmetry. What is the direction of E at point P? 1. Up. 2. Down. 3. Left. 4. Right. 5. None of above. Plus. P. Plus. Dash. 3. Set up integral, need to evaluate dq and express it in terms of a position parameter. Quiz 2, the 26th of February 2001, Friday. Two charges are fixed on the perimeter of a circular clock face. Plus q is placed at 2 o'clock, plus 2q is at 12 o'clock. Where should a third charge be placed on the perimeter so that the electric field is 0 at the center, point P? What relative charge strength is required at that point for the electric field to be 0? Gauss law. Quantitative relationship between electric field, direction and magnitude, on a closed surface, Gaussian surface, and total charges inside the Gaussian surface. Flux of electric field measures how much field through a surface. Direction of surface, the, normal to the surface. Flux is a function of E, R, and dot. Therefore, equals 0 does not necessarily mean E equals 0. Apply Gauss's law. R. L. Two types of Gaussian surfaces. R. Apply Gauss's law 1. Point of interest has to be on Gaussian surface. 2. Choose Gaussian surface so that E can be taken out of integration. Explore the symmetry of E. E are the same everywhere on surface. Sphere often equals 0 or 180, so that cos 0 equals 1 or cos 180 equals 1. A surface, a line on the surface, cos 90 equals 0. Combination, cylinder. Symmetry of E. Gaussian surface. Spherical, point and spherical charges. Sphere. Cylindrical, line charge. Cylinder. Planar, sheet of charge. Box or cylinder. Apply Gauss's law. 3. Add all charges inside Gaussian surface. Algebraic sum. 1 less than 0. 2 greater than 0. Plus outside. 4. Calculate E. Concept check. Gauss law. B. Q. Plus Q. P. Plus Q. P. Plus Q. P. Which situation has more electric flux through the closed surface? Which situation has the largest T at the point P? Gauss law. Important properties of metals. In a static, no charge motion condition, there cannot be excess charges in the interior of a metal. All excess charges must be on the surface. An equivalent statement, ion equals 0.